Hey, I'm Joshua A.C. Newman. I wanted to introduce you to this effects thing that I built. Not because you can build one like it, because it's built out of an Axolotl core, and that's not really available anymore. But the voltage control system that I'm using is super simple, and I thought it could help you figure out what you want to do if you want to circumvent toys or synthesizers that weren't meant to do interesting stuff. So let me show you what it is. Let's take a look. So what we've got over here is called Kerberos. It's 3 separate low-frequency oscillators. And I'll be introducing you to this in a different video. I'm pretty psyched about how it works. But it's not the subject of this. Right now, all it's doing is giving you this variation that's slightly irregular in voltage. Now, what that's doing is it's sending in a signal to the pitch compressor on the voice nodulator. So the pitch compressor takes the highest frequency sounds and turns them down. Not just as a filter, but also pitch bends them. So you can make these really creepy low sounds out of the high sounds. This is a high-pass filter, so I can affect all of what is coming through. So you can hear that my voice is now turning into this, I don't know, cyberpunk grumble. The voice nodulator does all sorts of cool stuff. We can use it to lock a sound in amber by flipping the switch. And what you'll hear as we clarify this is that when I open the switch, we catch that little piece of sound. And we can leave it open and use it like an effects pedal. But we can also catch a single word and use it and do whatever we like with it. So, because this is all voltage controlled, we can mess over here on Kerberos. I'm using channel 2 here as my output. It's going over to the oscilloscope through this cable, and then this gray cable is going in to control the frequency that the pitch compressor is affecting. We can change, of course, because it's a low frequency oscillator, we can change the frequency. So we can turn this up, that's the level. We can turn the frequency up. We get these other weird effects like this. And I actually really like this one. There's a point where, there we are. Now the frequency of that low frequency oscillator is being modulated by channel 1. Channel 1 is being modulated by channel 3. So it's not a loop, but they're all making it so the frequency is irregular, as you can see. Let's turn that frequency down a little bit so we get, there we are. So we're just pushing into audio frequencies. And this is pretty fast. I'd consider doing this with a Vactrol or an optocoupler kind of thing. I've got a ton of them around. But the distortion on the signal, it was okay, but the biggest problem was that as you got up close to audio frequencies, the signal basically just went away. So if we turn this way up, then we get effects like this. That's pretty neat. So what this is doing is turning this knob back and forth real fast. Right now it's coming out of a sawtooth, but we can put it into a triangle. Let's get this a little more legible if we can. There it is. Okay. There. So you can hear how that shifts. Let's get it down here. Yeah, all right. That's getting pretty weird. So let's turn that frequency up a little bit more. Hey, come back. There you go. This is the frequency range that I'm adjusting. There we go. Yeah, look at that. Yeah, it's got some weird stuff going. Let's turn it down a little bit. Then we can fine-tune it with these other knobs. As you might surmise, I don't care that much about 1 volt per octave on this kind of machine. So let me show you how it's working by popping this open. Now this is, as you probably guessed, an all-digital circuit in here. Let me zoom you in. So this is an Axolotl core, and they're not available anymore, even though they're really cool. Johannes had to touch every single one, and I think it just became overwhelming keeping up with demand. And there was another, the AXO project, which was a fork, and it wound up with the same kind of problem. So this thing I sort of treasure, and I'm hoping that there are other development boards that sort of fill this space in the future. But what I want to show you here in particular about this is that this is how the control voltage is working. That cable is coming into this jack right here. Then coming over here, you can see here it's got a resistor. And here's this other resistor that's coming out of the potentiometer. So what's happening is the potentiometer and the control voltage are being mixed, and they're being sent into, and this part's pretty unusual, this is a MOSFET, and it's operating in the ohmic range, which means it's acting as a dimmer rather than as a switch. So the output is coming out of the MOSFET and then going into the board. So what's happening is it's all being constrained to the usual 3.3 volts that this speaks. So even though I'm sending it a 5-volt signal, it's being scaled down appropriately for this digital 3.3 volt circuit. And it's what's really cool about this is that it just straight up is working. It worked the first time I put it together. And I suggest you give that a shot. I'll be posting the schematic up to my patrons in the next day or so. And you should come check it out. It's very simple. I'd love to see what the downsides of it are. I haven't been able to get it to overheat. I haven't been able to get it to do anything weird at all, frankly. It's just behaved really well. And as I understand it, the relationship of the input to the output gets nonlinear at the top end of the range, but that's around 10 volts, so that should be fine for our Euro rack -5 to +5 10-volt spread. It might get bent up at the top end. I don't know. I'd love to see some experiments. So let me know if you try it and how it works. Part of what's exciting about this is that it is about 11 cents in parts, I think. The transistor I'm using is this one here, the 2N7000G. It's made by Microchip, and it looks like a regular transistor, but it's a MOSFET. It doesn't have a heat sink or anything, but it works really well, and it's a really super simple circuit. So I look forward to seeing what you do with it, and come back and post your videos or links or whatever in the comments below. And I'll take it subsonic here with you, just play the Nodulator here for a little while and show you the kind of things it can do. speech. Bell-like sounds. Made from speech. That float. On a sea of sound. Thank you for hanging out with me to do this little experiment. And I look forward to just doing some art here with you in future videos. I'm excited about this control voltage system I've got here, but I'm most excited to make weird sounds. And I want to share them with you. Because if we listen to any sound enough, then it becomes music. The music happens in your mind.